Greetings to all of you. In this session, we are going to discuss about intermediate chemistry, which is helpful for international entrance and competitive exams as well. In India level, JEE Advanced and JEE Mains for IIT and NIT entrance examination, that is engineering stream, NEET exam for medical entrance exam. So this intermediate content is very much helpful. Telangana and Andhra Pradesh MCET examination for engineering entrance exam. So these concepts are very much helpful. In addition, if you are preparing for any competitive exam conducted by the government organizations, there will be a compulsory content, a compulsory segment will be there, which is called a general studies question paper, where the content what we are discussing will be given, right? So that let's enter into our today's session. Explain the name of following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. As per the IUPAC, what will be the name of this compound we have to assign, right? So this is the kind of compound where you can find 1, 2, 3, 4, 5, 6. All 6 are present in one cyclic ring, and another will be there with the 1, 4, 5, 6, 7. This is another 5-membered ring. So this is a kind of a typical bicyclic system, we can say Narbornane. So for this compound, we have to assign IUPAC protocol, IUPAC nomenclature, right? So in order to assign naming for this compound, first of all, we have to mention it is the bicyclic compound. So that let me mention bicyclo. It is the bicyclo compound. In this bicyclo compound, with respect to this ring structure, left side how many carbons are there? The 6th carbon and 5th carbon. We can indicate 2 carbon atoms are there. Right side how many carbons are there? 2nd carbon, 3rd carbon. Again you can count 2 carbons. In the top side how many carbons are there? This corner, this sharp corner is having 1 carbon only. So that left side 2, right side 2, top side 1. So let me mention 2 comma 2 comma 1. Okay, whenever bicyclic system is taken into the consideration, these carbons also accounted in the square bracket, right? 2 comma 2 comma 1. So being it is the bicyclic system, bicyclo is there. 2 comma 2 comma 1 is mentioned over here. Later on, total carbons to be counted. Total number of carbons are 1, 2, 3, 4, 5, 6, 7 will be there. 7 carbon parent chain will become heptane. So complete name of the compound will be bicyclo 2 comma 2 comma 1 heptane. So simply we can say Narbornane. Narbornane is the common name, and bicyclo 2 comma 2 comma 1 heptane is the IUPAC name of this compound. Move on to question number 2. This is collected from Cambridge Assessment International Education. The covalent molecule M contains total of 4 shared electrons. What is M? So here compound is given whose condition is covalent molecule. Sharing of electrons are required, and they are saying 4 shared electrons will be there. The options are ammonia, hydrogen chloride, methane, water. Among all which is sharing 4 electrons among 2 atoms or multiple atoms is to be predicted. Okay. For that purpose, let me take ammonia first. Ammonia geometry is taken as a tetrahedral, and its a shape will be what pyramidal in nature, right? So if you see nitrogen is associated with the 3 shared electron pairs will be there. This is said to be 3 covalent bonds. 3 covalent bonds indicates 6 electrons. So shared electrons are 6. Unshared electrons are 2. So here is the distinction. Here is the separation between the shared and unshared electron. These 2 electrons are not participating in any bond formation, and they are purely of nitrogens. So that we can say these are non-bonding electrons, and whatever electrons participating in covalent bond will count for this sharing of electrons. How many are there? One bond indicates 2 electrons. 2 plus 2 plus 2. Total 6 electrons are in sharing. Move on to hydrogen chloride. In this hydrogen chloride, hydrogen is giving 1 electron, chlorine is giving 1 electron, both are shared among. So shared electrons are only 2. In case of methane, methane is a tetrahedral molecule. Each carbon is contributing one electron, each hydrogen contributing one electron. So that total possible electrons are 2 plus 2 plus 2 plus 2. Total 8 electrons are shared among carbon and hydrogen of methane. So 8 electrons shared. In case of water molecule, you can see it is the bent molecule. Bent shape is acquired and tetrahedral geometry is assigned for the water molecule. Whenever water is taken into consideration, oxygen is forming bond with two hydrogen atoms. So, two hydrogen bonds are indicated with the 4 electrons. So, 2 2 plus 2, 4 unshared electrons are there, 4 shared electrons are there. Here is the condition required is shared electrons. So that I have shared electrons of 4 in count. So 4 is the required answer what they are asking. 4 shared electrons containing molecule is water. So the M will be water. For question number 2, option number D will be the correct answer. Move on to question number 3. Question number 3 is collected from organic chemistry. Moreover, stereochemistry we can say. Here, it is the biomolecule called erythrose, de-erythrose. Its a Fisher projection is given. Fisher projection denotes what? Vertical and horizontal bonds are indicated. So on two-dimensional paper, Fisher projection is given in the two directions only, two dimensions. Hence, we can say it is a 2D structure, right? So in this Fisher projection, the compulsory condition highly oxidized form will be taken up and all the carbons are hanging in the subsequent positions and we can put a molecule in the straight chain, right? So this is the way de-erythrose is given. So it is the Fisher projection of de-erythrose and it is of 4 carbons with aldehyde and 3 hydroxy functional groups. With this de-erythrose, isomers are listed P, Q or S. These many isomers are given in the column 1 and what kind of relation they exist with the de-erythrose in the column 2 we have to map. This is the kind of match the following. So all these are the kind of molecules provided in the Sahar's representation. Right, molecule can be represented in Fisher projection, Newman projection, Sahar's projection will be there, three-dimensional representation will be there, molecular formula representation. So many kind of observations you can notice. Among all, this is the kind of representation is called a Sahar's formula, Sahar's representation. Okay, in the Sahar's representation, molecule 1, that means P, what kind it will be with erythrose, either diastereomer, identical, enantiomer, what relation you can notice, and Q. So this is in either form and what kind of change you can find. So for all these kind of conformations, you have to find out its relation with the de-erythrose. In order to get the relation, either Fisher projection to be converted into Sahar's or else Sahar's can be converted into Fisher. So it is very simple to convert the Sahar's formulas into Fisher so that you can easily compare. Comparison will become more convenient. That's the reason why all the molecules are converted into Fisher projection only. So this is the reference compound. With this you have to compare, no? So that reference compound is in Fisher projection de-erythrose. Compound P, if converted into Fisher, so it will be represented like aldehyde with OH, OH, CH2OH. If you observe, both the compounds are exactly similar. Aldehyde is there, OH are right side, and the CH2OH will be there on the terminal carbon. So that we can say de-erythrose and the compound P both are exactly identical, right? Move on to compound Q. Compound Q, if shifted from Sahar's to Fisher projection, you can notice OH is left hand side and either OH right hand side. This is the way you can represent. If you observe OH right side in erythrose, but OH in alternative sides in a compound Q. So if compound Q placed on compound erythrose, what happens? Neither superimposable nor mirror images. so that we can say both are diastereomers. So the condition for diastereomers, neither superimposable nor what mirror images. So if you put a plane in between these two, you can't identify, both are not exactly resembling. And if molecule placed on this, it is not superimposing, so superimposability is not there. And also mirror image reflection is also not there, so that we can say this erythros and Q are said to be diastereomers. And compound R, it is the kind of representation. Here, second carbon OH is right side, third carbon OH left side, just a reciprocal of this one, just to be inverted this kind of second and third carbons of compound Q. So if this also placed on this, you can't find any superimposability and mirror image reflection. Again, we can say it is also diastereomer. Diastereomers are the isomers which are neither superimposable nor mirror reflection to each other, right? And compound phi, if taken into the consideration, compound phi is having OH left hand side. If you are taking compound S and placed in front of erythros, both looks like mirror image to one each other. If you are seeing your face in a mirror, what happens? You can find the reflection. So what reflection you can notice, whatever erythros is there, if you put a mirror over here, its a mirror image will be like a S. So that the erythros and compound S both are mirror images but non-superimposable. That relation is called enantiomers. That enantiomer relation will be there, which are provided in a option number C, P2, Q1, R1 and S3. P2, Q1, R1 and S3. That relation is provided in option number C. This is purely from stereochemistry. It is somewhat critical question, we can say. So if we know how can we convert this Sahar's dimensions into Fisher, then only it is possible to draw the relation between these projections with the diastereomer identical or enantiomeric relation. For that purpose, we have to understand what diastereomer relation is exactly, what is mean by identical molecule, what is enantiomer. So if the entire concepts are known to you, then only we can answer such type of complicated questions. For question number 3, option number C will be the correct answer. Move on to question number 4. Question number 4 is also the part of organic chemistry. With respect to the compounds 1 to 5, 1 to 5 compounds are provided. The correct statement or statements are, okay. Among all few statements are provided, we need to identify which are exactly correct with respect to these many compounds. The acidity of compound 1 is due to delocalization in the conjugate base. Okay, so this is the compound. If you see here, carbon is there, that carbon is of sp3, and around this carbon atom you can find 3 phenyl, that means 3 benzene rings are located. All benzene rings are planar, and this carbon is sp3 hybridized. If you are making its conjugate base, conjugate base means any two compounds differed by only one hydrogen is called conjugate acid base pair, right? So if you see this compound, triphenyl methane, here also triphenyl methane is there, but methyl anion is there. One difference is hydrogen got removed. We pulled one hydrogen so that carbene will be generated. This carbene, what they are asking, in this conjugate base, delocalization is possible, and so that the compound is becoming acidic. But being it is a kind of sp3 carbon and the bulkier groups around that, it is sterically highly hindered, so that it will not favorable for the removal of H plus and stability delocalization of this negative charge. Though this negative charge is in conjugation with all these rings, conjugation is available, but there is a steric hindrance. Steric hindrance plays a vital role over here, so that we can't say it is not that acidic. So compound 1 is not that acidic with respect to steric hindrance factor, right? So move on to option B. Conjugate base of compound 4 is aromatic. Compound 4 is compulsory condition for aromatic nature will be Huckel rule must be satisfied, and all the carbons are planar in nature, and the compound must be cyclic in nature. Few criteria will be there in order to give the compound as aromatic. So that if you see this compound, one of the carbon is sp3 hybridized, so that we can't say this is aromatic. This is non-aromatic compound because one of the carbon is of sp3 hybridized. No, here you can find no double bond, no carbocation. So this is non-aromatic. But they are saying that conjugate base means let's pull one hydrogen from this. Whenever hydrogen removed, one of the hydrogen got removed from this carbon atom, now it converted into minus charge, cyclopentadienyl anion. So this is called a cyclopentadienyl anion. If you see 2 plus 2, 4 plus 2, 6 electrons are there. 6 electrons are nothing but it resembling benzene like. So that 4 and plus 2 rule will be obeyed, and it is like a aromatic system, so that we can say it is the correct answer only. Compound 2 becomes more acidic when it has NO2 substituent. Whenever compound 2, they are saying compound 2 is simply benzene. So this benzene is not acidic actually, but what they are saying, it will become more acidic whenever NO2 substitution is introduced. NO2 will be the substitution over there. If NO2 is the substitution placed on this benzene ring, what happens? Always electron withdrawing groups are having tendency to pull the electron density towards them. Whenever electron density is pulling towards this electron withdrawing group, these bonded electrons are strongly attracted towards benzene ring, so that H plus easily removed, so that acidic nature of benzene ring will increases. This is clearly explained by taking any other example. I'm not getting exactly similar. That's the reason why I'm comparing with this. So here fluorine, instead of nitro, what I am using is fluoro. Fluoro, nitro, both are said to be electron withdrawing groups only, and both are having the nature of negative inductive effect. That means withdrawing inductive effect is occurred for them. So whenever electron withdrawing inductive effect is there, that having strong tendency to pull the bonded electron density towards that functional group, that is called withdrawing inductive effect. Whenever withdrawing inductive effect increases on the given compound, its acidic nature strongly increases. That is the fundamental thing, so that benzene will become more acidic whenever nitro substitution got increased. That is because of withdrawing inductive effect. So option number C is also the correct answer. Acidity of the compound in the following order. They are saying compound 1 is more acidic, triphenyl methane, and compound 4 is next level, that is cyclopentadienyl anion after the removal of this one, right? And the next is about acetylene. Simply this is called acetylene, and the second compound is benzene, and the next is about methane. This is the order they are saying, but it is absolutely wrong, because so in this compound here, whatever this cyclohexadiene is there, cyclopentadiene is there, this will become more acidic, because whenever one of the hydrogen removed, it is becoming aromatic. So any compound becoming aromatic is a stronger tendency to remove the H plus, no? That's the reason why it will become more acidic among all the given options. This is not the correct order. And moreover, this after this one, we can't say acetylene. Acetylene is a sp hybridized carbon. That's why its character increases, carbon electronegativity increases. That is a factor. But here electronegativity of nitro group pulling tendency will be more, no? So that exactly what they are mentioning is not correct order. So here fourth compound will come as the starting one, because it is becoming aromatic. So for the given question number 4, option B is correct. Option C is also correct. Let's move on to question number 5. Question number 5 is collected from Telangana Gurukulam Common Entrance Examination for the degree college lecturer. What is the pH of 2 molar aqueous hydrochloric acid solution if ion activity coefficient of H plus ion in the solution is 0.1. Assume complete ionization of HCl. Hydrochloric acid is the strong electrolyte. That's why completely ionized. We are taking 2 molar aqueous hydrochloric acid solution. Its a concentration is given to you, and its ion activity coefficient is also given to you. pH calculation is required. So pH values are provided. Among all, the correct answer will be pH is equal to 0.9, 0.699. Let's see how can we get this. pH is defined as negative logarithm of molar concentration of hydrogen ion. Negative logarithm of hydrogen ion concentration is called the pH of the solution. The unit of the concentration hydrogen ion moles per liter. Whatever hydrogen ion concentration taken, moles, number of moles present in the 1 liter solution. Okay. The pH formula will be pH is equal to negative log of H plus ion concentration. Let's put all the values whatever you know. pH is equal to negative log of H plus ion concentration is given as 2 molar and activity coefficient is given as 0.1. Let me multiply 2 into 0.1 so that it will become 0.2. So negative log of 0.2, negative log of 0.2 is given as 0.6989. So 0.6989 you can round up as 0.699. So 0.699 is given in the option number 4. So if 0.69 is there, that solution is said to be acidic in nature. As per the Sorensen scale, the solution is said to be acidic. Acidic solution will be there. For question number 5, option number 4 will be the correct answer. Move on to question number 6. Question number 6 is given from kinetics. Chemical kinetics, it will be when the temperature rose from 420 Kelvin to 466 Kelvin, rate constant of the reaction also changed. As temperature changes, rate constant changes, that nothing but Arrhenius equation. Okay. So if temperature from 420 Kelvin to 466 Kelvin, rate of the reaction increased from 2.3 into 10 to the power minus 3 to 0.23 second inverse. And you can clearly notice it is the first order reaction. Which of the following is the closest activation energy of the reaction? Closest activation energy to be calculated, to be identified. Take R is equal to, gas constant R is taken as 2 calories mole inverse Kelvin inverse. Okay. Using this data, we need to go for the calculation of activation energy. So for that purpose, we have Arrhenius equation. Arrhenius equation is temperature dependent. Arrhenius equation is defined as how the rate constant will be changed as per the temperature. As temperature rises, rate constant also changes. That relation is called Arrhenius. Arrhenius equation is given as K is equal to A into e to the power minus EA by RT. K denotes what? Rate constant. A is nothing but what? Activation energy. And e to the power, E base. So base E, it will be EA is the activation energy, R is the gas constant, T is the temperature. Okay, so A is the Arrhenius constant here. This is the kind of equation. In case of this one, you can find a rate constant relation with the temperature. And we can take the ratio as well. So if two different rate constants are present, K1 and K2, if K1, K2 are available, let me put log of K2 by K1. Log of K2 by K1 is equal to EA by 2.303 R T2 minus T1 upon T1 into T2. This is the equation when two rate constants are present and two different temperatures are there. So as we already aware, as temperature changes, rate constant changes. If you are shifting from T1 to T2, K1 will shift to K2. So that relation is given by equation number 2. Log K2 upon K1 is equal to E upon 2.303 R T2 minus T1 upon T1 into T2. This equation we can use for our calculation, right? So here K2 value is known to you, that is log of 0.23. K1 is 2.3 into 10 to the power negative 3. EA to be calculated, activation energy 2.303. As such, you can put the numeral. R is the gas constant, 2 calories. T2 is the 466 Kelvin, and T1 is 420 Kelvin by T1 is 460 Kelvin, T2 is 466 Kelvin. So let me multiply. So from this equation, the required term is EA, no? So that whatever terms are related with EA are there right side, totally we shifted left side and left side to right side. Just equation got reciprocated, reversed. Equation right side to left side to right side. So equation reversed. After that, EA left hand side only let me put, and denominator terms are going up. So that EA is equal to 2.303 into 2 into 466 into 420 by 466 minus 420. If you calculate this one, we will get the value near 39.14 into 10 to the power 5 calories mole. That is given in option number 2. This is purely numerical problem based on chemical kinetics. Okay, so we have to go with the Arrhenius equation related with the different temperatures and different rate constant values. For question number 6, option number 2 will be the correct answer. By this, entire session got completed. Hope this will be helpful for your preparation, and entire content whatever we chosen today detailedly explained. I hope this session will be helpful for your preparation either towards entrance or any competitive exam you are seriously preparing for. Hence, I'm sincerely requesting you all to like the channel, comment which part is really informative for you, and share with the aspirants who are seriously preparing for any competitive exam or entrance examination. Subscribe the channel to receive more updates, and thank you very much for your patient listening.